Hey, what's
Hello?
up?
Hey, what's up, Joseph? How's it going, bro?
Good, you?
Good. Trying to figure out. I was watching that last part of the video right now about the doing that solving that problem with the letters.
Yeah, it was just letters, right?
Yeah, I remember you were trying to get the H on its own, and you kind of had to do the same. I mean, we could try it when I just watched it right now. So.
Actually, can I like make
You
up a
want to say
couple
something?
things and like show you for like 5 minutes and then start it?
Yeah, go ahead.
Okay. All right. Let's see. So what we had started out, it was just like S equals 2 pi RH, 2 pi RH plus 2 pi r squared. So for this, we were solving for h, and that just means getting the h all by itself, which also means you start with the thing farthest away from the h, which would be all of this stuff, and
Mm-hmm.
this doesn't have an h involved. So we subtracted that over uh, to the other side. Like we subtracted it over, so it became negative over here, and then we divided off the rest of this stuff because it was multiplied there. There's a couple different things that will happen. So like this, I think was a good example of some variables. Like it, I think all these questions in some way will be um, having some variable that you have to get by itself. So like I'm just gonna make up something, but if you had like let's say z p squared q minus, I don't know, 10 z equals 21. There's so like if I were to say solve for q, that's the same as this problem. Like it's getting q by itself. So there's two terms here. There's this term, and then there's this minus 10z. That's the other term. I guess there's three terms because there's this 21 over there. But to get the q by itself, we're looking at the same side of the equal sign as the q is. So like the left side, because q is on the left side of the equal sign. And you deal with the thing furthest away. So that would be this 10z or minus 10z. We would add 10z to both sides plus 10z. This doesn't have a z, so we can't combine anything. Those cancel out because we have the minus and the plus, and they're exactly the same otherwise. So like negative 10z plus 10z cancels out. And then we would have zp squared q equals 21 plus 10z, because we can't add those together because one has a z and one doesn't. But our whole goal is to get q all by itself. So q is being multiplied by p squared and z. So I just have to divide off both of those. So divide by z p squared, and then do that to the other side. Divide by z p squared z p squared. So that part cancels out, leaving me with q. And then I have 21 zp squared plus 10. Actually, these z's cancel out. So then I just have 10 and then a p squared on the bottom that stays on the bottom. Like that's one way you could write it. They could say like solve for a different variable. They could say like solve for z, but we haven't gone over factoring yet, so I don't think they would say something like that. So it really is just, at least for this type of problem, focus on, so like solving for q, that means, okay, look at the left side first because q is on the left side of the equal sign. And then start with the term furthest away from the q, which would be the negative 10z. It's furthest away, but still on the same side of the equal sign. So then do the opposite, and then do the opposite of the stuff that's closest until you have q all by itself. I mean, that's the general idea for solving for a variable, even if there are no numbers. So we'll see. But it's the idea is look on, like, first figure out what you're solving for, and that just means getting it by itself, and then looking for the furthest thing away. So like the minus 10z be furthest away. This stuff you consider closer to the q. So you deal with the farthest away from the q first, and then get closer and closer to the variable that you're trying to get by itself. I don't know. We'll see some problems hopefully.
Yeah, see, especially these guys, who knows what they're gonna say.
Yeah.
We did the one. Oh, that's kind of the same, right? This one has more. But...
Yeah. So you see how there's an A on both sides?
Mm-hmm.
You can treat it similar to like what we've done before. Like get the A's to one side. So I would say get the A's to the left side. So like subtract 5a because it's a positive 5a on the right side of the equal sign. So subtract 5a from that so that it cancels out, and then subtract 5a from the 7a, and then that way your a's are on the left side. And then
what about the double b's?
Yeah, the two. So then you do the same thing, but for the minus 2b, you do the opposite to that and put it over to the other side. So you would do plus 2b underneath the minus 2b, and then a plus 2b with the b to make 3b. So then it's like b's all the way to the right side.
Okay.
See if that makes sense and see if you get something, and then I'll check you, and then if not.
All right, so I'm going to go with the 5a subtract.
Mm-hmm.
That's going to cancel that right side out, right? Mm-hmm. I'm going to subtract it from 7. So that would be 2a, right?
2a, and it's on the left side, yeah?
Yeah. Uh-huh. And then it's going to be 2a minus 2b
mm-hmm.
equals b.
Mm-hmm.
So then from this point, do I add the... So then I'll add the 2b and go over to the right?
Yep. So you basically moved the 5a by subtracting it from the right side and subtracting it on the left side. You moved that over, and then now you're moving the 2b over by doing the opposite, adding 2b on the left side. It cancels out, and then you add 2b on the other side.
All right, so now I'm left with the 2a equals 3b.
2a equals 3b. So if you're solving for a, that means you're trying to get the a by itself, and the 2a is the same thing as 2 times a. So if you want to get
so it cancels out, right?
Yeah.
So it's going to be like 2a plus 8 times a, and then we have the a.
It will be, so it's 2 times a equals 3 times b. That's what it's saying. But you're trying to get the a by itself. So you do the opposite of 2 times a, which is dividing by 2. So like to get rid of that 2 in front of the a, you divide both sides by 2, just like if you're solving it. Yeah.
Oh, okay. Okay.
So you divide 2a, you divide it by 2, and they cancel out. And then you divide by 2 on the other side. So it's 3b divided by 2.
So it would be the third one down.
Yeah. And so like the way that if you had like 3b all divided by 2, it's the same thing as putting the b in the middle of that little fraction. So it's like 3 over 2 times b. That's the same thing as 3b divided by 2. Like it makes the same thing. The only thing that's different is if the b was completely on the bottom, like 3 divided by 2b, that would mean something completely different. Like that's not the same. But when you write the 3b over 2 or 3 halves or 3 over 2 times b, that means the same thing. But the answer is the third one.
Yeah. All right, that wasn't too bad. So far.
We'll see. It was a different type, but
yeah. You'll see.
Okay, I think if they wrote it out like k equals c plus 273.15, if you write it all out and then just try to get the c by itself, you'd be able to see what it is. Because that's what it's saying.
So I would write the k, or c equals k.
Well, you start out with what it says on the.
Oh, how they wrote it out, huh?
Yeah, it's just like so it's just k equals c plus that, and then you try to get the c by itself by doing the opposites for whatever is farthest away from the c, and then if you need more, you do whatever's closest to the c. But
at the 273, that cancels out, so that just leaves k equals c over 273,
right? So you subtracted it, right?
Yeah.
So, but then you have to subtract it to both sides. You have to do it to both sides. So when you canceled it out on the right side, that's good. But then you still have to subtract it from the left side. So it should be k minus 273.15.
Oh, okay. Okay. Yeah, because I wanted to see. I'm supposed to get the C alone, right?
Yeah.
Yes. Okay.
Do you want me to show you, or think you got it?
No, I think I just went to the C instead of the K. So I canceled out the far right side, and then I went under. So it's K. It should be C equals K minus 273.15.
Yep.
All right.
That one's not too bad.
It's pretty interesting.
It's just written backwards, so like the way you get it is backwards from what they show for the answer. Do you know what to do on this one or no?
Is it the same kind of thing?
No, this one's different. They give you something to plug in. So it says,
Oh, so I can put it either it's R. I mean, it's 4, 8, 12, or 16.
well, do you see that last like little equation? It says R equals C divided by 2 pi.
Yeah.
So they solved it for R, which means you can plug in any C value and then see what comes out for R. Like you plug in the C and then you divide it by 2 pi and then see what comes out for R. But then they tell you that their circumference, so it says find the radius of a circle that has a circumference of 16 pi. The circumference is C in that equation. So R equals 16 pi divided by 2 pi. So if you wrote that down, R equals 16 pi divided by 2 pi. If you wrote that down, then you can cancel out the pi's because it's 16 times pi
Oh,
and
okay.
then 2 times pi, and then it's just 16 divided by 2.
Mm.
And
And that is 8.
yeah,
And that is the answer.
yeah, that's one way that you can do it. I think that's the way they intend for you to do it, to
Okay.
like to plug in that C. Otherwise, you could plug in the R to like the C equals 2 pi R. You could do 2 times pi times R and then see if that equals 16 times pi. Because,
I think the
I
other
mean,
one was pretty
they
better.
give you the C value, so you can just plug it in there.
Cool.
Hmm. So I think, I mean, it's written really poorly, but I think it means A equals 60 times the fraction G divided by T, maybe. But it's just written on 2 separate lines, so it's hard
Put together.
to tell. Yeah.
So if I were to write it out, it'd be A equals 60.
Parentheses G
Yeah.
over T. Yeah. But this time, so like the 60 is in the middle of the little fraction. So like you can do 60 and then there's a fraction G over T. Another way of writing it, it's the same thing, is if you do 60G, all of that divided by T. Those mean the same
Oh,
thing.
okay.
And then if you want to get the G by itself,
So it would be A equals 60G.
60G, and then the line
Divided by
underneath, yeah, all of that divided by T. Can I show you this one, actually?
Yeah, for sure. Yeah.
All right, so, like I think it'll be pretty quick. Just let me share.
It's-
So originally it's like this, but this is the same exact thing. And I'm thinking that's what you wrote down. Yeah.
Yeah.
Okay. So it said to solve for G. So I'm trying to get this by itself. And in this instance, the thing that's farthest away from this G is but still on the same side of the equal sign. The thing that's farthest away is the T. So I have to deal with that first because it's the farthest away. So I have to do the opposite. Here I'm dividing by T. So the opposite would be to multiply by T. and I have to do it to both sides. So that would cancel out there, and I would have 60g equals, and then t times a, that's the same thing as a times t. You could write t times a, it doesn't matter. Like, you can flip them around.
Okay.
So that was dealing with the thing farthest away, and then the next thing is the 60, and I think you know what to do there. You just divide by 60, so that cancels out, and then you have g equals a times t over 60, or at over 60. Because we're solving for g.
That's
so
it.
yeah, in this case,
Okay.
the thing farthest away was the t, so you do the opposite. It was divide by t, so you multiply by t to both sides. And then the next thing farthest away from the g, which is the only other thing, is the 60, and it's 60 times g, so you divide by 60, and then you get that.
Cool. I see now. This one here.
Yeah, at over 60. Yep. Solved for v. So there's a couple steps on this one.
If I were to write it down, it'd be the same.
Actually, I'm just gonna walk you through this one. So write down the original equation, d equals m divided by v.
Got it.
So it's asking you to get the v by itself, but to get the v by itself, we kind of need it on top. It's on the bottom right now, so we need it to be on the top. So you kind of have to do an intermediate step. You have to get the m by itself. So the first thing that you would do to get the v by itself is to multiply both sides by v.
Okay.
So on the right side, the v's will cancel out because you'll have a v like on the top to the side,
okay.
and it'll cancel.
Yeah.
And then you'll have a v times the d on the other side.
V times d equals m.
Mm-hmm. And then now, from here, you can get the v by itself. You just have to get rid of that
By
d.
dividing them. So I'll divide the d.
Mm-hmm.
So then it's going to be the.
So v's on top now. V's
MB,
v equals
v, right?
m. Or sorry, yeah. V equals what?
MD.
M
over d.
over d. Yeah.
Yeah.
Cool.
Yeah, that's something.
Mm-hmm. So I think the note is irrelevant. Like, you don't need to know that note. Just kilograms per, or kilogram meters per second squared. I don't think you need to know that. That's just for the units.
So this one I have to put in those numbers, right?
Yeah, like you do what you think, and then I'll check it, because I'm gonna do it also. Because I think you can do it without all the other stuff that we've been doing. I think you can just figure this one out, maybe.
Do I still got to put like F792, or just I could just put like 792 and then 3.6?
So you see the equation F equals ma.
Mm-hmm.
That's F equals M times A. So they give you the M. So it would be 3.6 times.
Yeah.
And then
M, right?
the A. So the 3.6 is the M. So you're going to do 3.6 times, and then the A, those are all the answers. Those are all A values. So like 3.6 times 0.5. Does that equal 7.92? Yes or no? And then you try 3.6 times 1.8. Does that make sense?
Yeah.
So they're giving you A values to plug in.
To equal the 7 point. Cool.
Yeah.
All right, it's a 2.2 then.
Yeah. It's weird because, I mean, they say the formula F equals ma, and I guess they say A is acceleration. There's just so many steps to interpret, but it says using this formula, what is the acceleration? Because they're asking you for the acceleration, and so that means all the answers are accelerations, which is the A in the formula. Okay, so in this one, it's just saying solve for t. So get t by itself. So you start out with the equation F equals V plus AT.
Okay.
And that's the same thing as A times T. So the T is on the right side of the equation.
So we're going to do the V, right?
Yeah, you start with the V. So what do you do with the V?
We subtract.
Because it's a positive V, so you minus it to the other side. So what do you get on the other side?
Just a subtracted B, right? Because what would you get over the AT? It's already solved it, right?
So if you subtract the V on the right side of the equation, the V's cancel out because you have V and then you do minus V underneath it and you cancel those out. But then you do an F on the other side and then a minus V under that, but they're not the same variable, so you can't like cancel them out or anything. So you just write F minus V. You just write it sideways, F minus V. And then the equal sign and then AT. And if you're trying to get T by itself, what do you have to do with that A? Do you think?
Gotta go divide.
So the way I've been doing it was divide. So like you have F minus V equals AT. I would divide the right side by A and then cancel them out. And then on the left side, I would divide both the F by A and the minus V by A. But another way of writing that is just to put a line underneath F minus V, the whole thing, and then with the V underneath, yeah.
So it'd be A.
Yeah. LA equals pi RS. Oh. This is a tricky one. It's asking you select two correct answers. So it's asking you to start with LA equals pi RS, start with that and get R by itself, that's one answer. And then start over and get the S by itself, and that's another answer.
It's just pi RS, right?
Yeah, LA equals pi RS. And you kind of do the same thing in both situations, but just with a different letter. So LA equals pi RS. Say you want to get the S by itself first. What do you think you would do?
The I don't know, would we get the pi and divide it? And
Yeah.
That's the furthest thing away, right?
Yeah. In fact, the pi and the R, they're both being multiplied. Like you're not like adding pi and then multiplying by the R. So like they're actually, I mean, you could consider it the same distance away. Just because you could write pi R S, or you could write
Okay.
R pi S. So you can actually divide by pi R to both sides.
Both together.
Yeah, together.
So that cancels that out.
Mm-hmm. So S is already
Right.
by itself. S equals.
So LA. Oh, S equals LA over R. I mean pi R, right? So this would be one.
Pi R or R pi. They just didn't write it that way, but those mean the same thing. Yeah.
Okay.
Okay, and then now start over and do the same thing, except for you get the R by itself. And you can still divide the pi S at the same time, even though they're like...
Okay, even though they're not right next to each other.
Right, because it's all just multiplication, so you can do it in any order.
So then it'd be this one here.
Yeah. Does that make sense?
Yeah. I just didn't know you can do that with the multiplication and adding.
Yeah. It's so like if it's...
If they're not right next to each other.
Yeah, if so, like when you get you're getting a variable like by itself, the thing that's farthest away is something that's either added or subtracted to it, to the variable that you're trying to get by itself. Something that's multiplied or divided to that variable, that's something that's a little bit more close. So if they're both like multiplied, then it's the same closeness, really. Yeah, I mean, that's it.
Interesting.
Okay, so this is getting the M by itself. So you start out with the farthest away, and then the next one is the close. So the farthest away is what from the M?
B.
Mm-hmm.
So we subtract B.
Mm-hmm.
Cancel that out, so then we get B minus Y equals MX.
Or you get Y minus B, not B minus Y.
Y minus B?
Yeah. Because if you write it, it should be the Y on top. The Y is positive. And then the B, you did a minus B, so the B is negative. So it'd be, Y minus B. Another way of writing it, if you wanted to switch them around, it would have to be negative B plus Y. But the Y has to be positive because it's already positive. You're not changing that part. But you're subtracting the B. So it should be Y minus B or negative B plus Y. Those two things mean the same. But it's Y minus B equals MX.
But now I have to get the X alone. I mean the M alone, right?
The M alone. So what do you do?
So then I would divide the X.
Mm-hmm.
So it'd be Y minus B divided by X equals M, or M equals.
Yep. There we go.
See how we do.
Yeah, the whole point of doing stuff like this is to be able to like figure out formulas without having to plug in any numbers. Like maybe you have some formula and you want to figure out a different piece of it, but you don't want to have to plug in any numbers. You just do it all before you plug anything in, and then afterwards you can just plug in certain things rather than plugging in then solving, plugging in then solving. You just solve once and then just plug in the whole time. But I don't even know like an actual.
Who uses the people? You ever use this like in real life?
No. Well, except for like.
I mean, you might have. I don't know.
Yeah. No, I can't think of anything like off the top of my head where I solved for something and then used it, unless I was like trying to calculate something where I never had to calculate. I could just Google it.
True.
All right, solving absolute value equations. Let me say something about this.
Right.
So an absolute value equation at the simplest is like the absolute value of x equals 3. What this means, like in words, is for absolute value, let's say just for absolute value. For absolute value, that means distance away from 0. So if I said like the absolute value of -2 on a number line, I have 0 here, I have -1, -2, I have 1 and 2. The distance, so if I say -2, okay, that just means this spot. If I say absolute value of -2, that means this distance, 1, 2, away from 0. So the absolute value of -2 is actually 2. The absolute value of regular 2, from here, it's just the distance away from 0, so 1, 2, is also 2. So
there's not -2 because it's going backwards or anything.
No, it's just the distance. And so like the way you think of distance is it's not going to really be positive or negative. You're just saying the distance between two things. So like the only way you'd make it positive or negative is if you're like talking about a certain direction, but we're not talking about a direction. We're just talking about just the regular distance between two things. So this equation means that there's going to be two answers. The way that you can think about it, like the steps to solve these equations are to, I mean, like you can guess what numbers that would work. Like you can plug in 3 to this and then just check, okay, well, the absolute value of 3, that just means the distance that 3 is away from 0. That's 1, 2, 3. Okay, so 3, if I plugged in a 3, that works. If I plug in a -3, does that work? If I plug in a -3, so I use -3, the absolute value of -3, well, if we're just talking about distance, 1, 2, 3, that distance still is 3, so -3, the absolute value of -3 is 3, and that's what this equation is saying. Like you can think about it like that, but the procedure, the steps to figure it out when it gets more complicated are really like this. Like if you had the absolute value of x equals, well, let's do 3. You can do two things. First, you can say whatever this is, just copy it down without absolute values, x equals 3. That's one answer. And then copy it down, but change the sign of this. So like x equals -3. That's the other answer. We're just flipping that sign. But it gets more complicated. If you said like x, let's do it in black, x plus 3 absolute value equals 5. Let's say this. We could just test numbers, plug it in, see if it works out. Or we can do this step and this step, which means one of them we're going to say whatever this is without the absolute value equals this number. So x plus 3. I'm just getting rid of the absolute value. And then the other one is getting rid of the absolute value but making this number negative. So like -5. I'll just change that to a negative and then get rid of the absolute value. This is
you don't have to plug in a number for x, like a 2 or.
No, like so. This is like a trick to be able to figure it out. So now we have two different equations, and then we're gonna see, and then I'll check it. I'll plug it in afterwards, and I'll check to see if it actually comes out to be +5. But this is a trick to figure out this x value.
Okay.
So the first thing, the first case, you just make two cases. The first case is just get rid of the absolute value, make it like a normal equation equal to whatever it says over here, and then solve this. So the way I can do that is by subtracting 3 from both sides to get the x by itself. So I get x equals 2. So that's one answer. I'll check that later. And then on this one, I just remove the absolute value, but change this to a negative, and then solve this. So I would subtract 3, but -5 minus 3, that would be -8. So that's the other answer. So I'm going to plug this in, see if I get 5. I'm going to plug this in and see if I get 5. I'm plugging in for the x. So let's see that. So absolute value plus 3 equals 5. So let's plug this one in first. So the 2 I'm going to plug in. And then the absolute value, if you're checking stuff, you just treat it like parentheses. You do whatever's inside the parentheses first. So you do whatever's inside the absolute values. You do that first. So 2 plus 3 equals 5. Then you evaluate the absolute value. But the absolute value of 5 is just the distance. No, where's my... The distance 5 is away from 0. 1, 2, 3, 4. I mean, it's just 5. Mm-hmm. So that works out. The absolute value of 5 is just regular 5. And if I plug in, so what do I have? The absolute value of x plus 3. So x, whatever that is, and that's supposed to equal -5. Sorry, not -5, regular 5. That's, I'm plugging it into this thing. But I'm plugging in my other answer, which is -8. And then -8 plus 3 comes out to be -5. And then I still have the absolute value. So the absolute value afterwards, because remember you do the inside stuff first. So -8 plus 3 is -5. But the absolute value of 5 gives you regular 5 anyway. So that also works. So the two cases that you make are write the exact same equation down without absolute values. That's what we had there. And then write the exact same equation down without absolute value, but change this number to a negative. And you solve those, and then they both work out. And I don't know what it's going to look like. It might be a little bit more complicated, but I mean, that's the general idea. If you have an absolute value equation, you just make two cases. One where it's exactly the same, and then one where it's almost the same. You just change the sign of the other number on the side. All right, let's see.
Let's see what they show.
There might be a bunch of like word problems. We'll see.
Yeah.
Are there 8 for each like little section? Like we're on number 2 or 3 right now. Like CR-3 or 2. What number?
We're on. This is So there's going to be, I believe, like 10 or something of this.
Oh,
one.
okay.
So this is a pretest. I don't know why it's going to be a pretest. No, this is the one. Never mind.
Manuela solve the equation. Oh, this is more complicated. Oh, there's more steps to this. Shoot.
So this ain't no simple freaking.
No. Let me see. Well, you could plug in stuff because it says what is the other solution. So those are answers that should work out. So like, pick one of those answers, then I'll walk you through how to plug it in.
Well, let's do a 4.
Okay, so
-4. Or 4, yeah, or let's do 4, regular 4.
Okay, so if we did regular 4, we treat the absolute values like parentheses, but we're plugging in, instead of the x, it'll be a regular 4. So that's like 0.5 times 4. You do that first, and then you do the plus 1.5. And you see what that is. So what is that?
So 0.5 plus 4 should be
times 4 and then plus
4 is 2 plus 1.5, right?
Yeah.
3.5.
So that's the inside of the absolute value, and absolute value just means the distance away from 0. So absolute value of 3.5 is still just regular 3.5, yeah?
Mm-hmm.
But then there's that -2 right there. So so we got to do, so it's like 3 minus 2 times 3.5. So we got to do times 2, which is 7, yeah?
Yeah.
So then we have to do 3 minus 7, because it was 3 minus 2 times all that stuff. And we did the 2 times all that stuff, and it was 7. So 3 minus 7.
It'll be 4, right?
It'd be -4, but it still doesn't give us the other side of the equation, which is 2, which means that answer is not correct. The x equals 4. So let's try, pick a different one, and I'll walk you through again, and then we'll see what it is.
All right, so it's going to be this. The 6 is -6. I'll do a 0.5 times 6 negative.
6 negative.
Was -3. Plus 1.5. Equals -4. 1.5.
Okay, and so the absolute value, because now we're at the point where we evaluate the absolute value because we did all the stuff on in the inside of the absolute value. So the absolute value of negative 1.5 is just 1.5, regular 1.5.
Hmm.
Because
so then we're gonna do we multiply by 2?
Uh-huh.
I got negative 3 again.
Well, it should be positive. Well, should be positive 3. Because the absolute value of 1.5 is positive 1.5. So you do 2
Okay.
times that 1.5, that gives you positive 3. But then you're doing 3 minus that.
So it'd be 0.
Yeah, it'd be 0. So that one doesn't work.
Okay, let's do 2 now. 1, 0.5 times 2 equals 1 plus 1.5 equals 2.5. That's the absolute value.
It stays.
Now I'm going to do a times 2 equals 5.
And then 3 minus
and then we're
that.
taking away minus 3, right?
Or 3 minus that, yeah.
It'd be regular 2, not negative.
It would be 3 minus the 5. So it would be negative 2. It ends up being negative 2 for.
Oh, 3 minus. Okay. Yeah, you're right.
So that one doesn't work. So let's try plugging in that negative 4 and see what happens. So that should be it.
Times. Yeah, negative 2.
Negative 2 and then plus the 1.5.
Got negative 0.5.
And then so the absolute value of that is positive. So positive 0.5 times that 2 equals 1. And then you're doing 3 minus that.
So I get negative 2 also.
But it should be the 3 minus that stuff.
3 minus, okay.
I think I want to show you that one. So, I mean, it's going to be the negative 4, so you could save and exit. Let me just copy this down real quick. Yeah. You're good.
Got it?
Yes. Yeah. So here we plug in the we plug in like negative 4. The order in which it's written, so it's like 3 minus all this stuff. So whatever, not this stuff. 3 minus all of this stuff. So when we plug it in, this is what I'm doing like in my head, or like when we're working out. This is how I keep track of it. So plug in the negative 4 for the x. So this stays, and I have 0.5 times negative 4, and then plus 1.5, and the absolute value equals 2. So the first thing that I do is this part. So we multiply that, and we get negative 2. The rest of the stuff stays there. And then I have plus 1.5. I'm working on the stuff inside the absolute value. So I still have multiple things on the inside of the absolute value, so I still work on that. So negative 2 plus 1.5 is negative 0.5. So I have this stays, 3 minus 2. And I have negative 0.5 inside the absolute value. And then now that I only have one number inside the absolute value, I evaluate the absolute value, because the absolute value of negative 0.5, it's just one number in between. So the absolute value of that is just regular 0.5. So I change this to just regular 0.5, and I change the absolute values to parentheses, because parentheses, I mean, this is still times. So if I just write this part out, it's still just times there.
Okay.
And this is the part that I think was a little bit confusing. Like, we did 2 times this to get 1, but then we still had the negative. And then, so it'd be 3 minus 1. A different way to do it would be negative 2 times this. If you included the negative and multiplied, negative 2 times 0.5 would give you negative 1. And since you included the negative here, you don't write down another negative. It's already included. So it'd still be the same thing, 3 minus 1. And that equals positive 2.
Yeah.
It's just a weird, like, the order in which you do things. Since this was on the outside, you could either do like regular 2 times, actually not times this, because you have to do the absolute value first. So the regular 2 times the 0.5 and then keep the negative, or include the negative and then just use it as part of the answer. So like negative 2 times 0.5 is negative 1, and so it becomes a 3 minus 1. Hopefully, well, we'll see. We'll see more. But
Okay.
it's just plugging in stuff.
I did need to remember to always change the absolute value to positive.
Yeah, and so like it's changing negatives to positive, and if it's already positive, it stays positive. That's what absolute values do.
Sorry. What is the solution to? So this one.
So we could plug it in, or I could, like, we could pause it and I could show you how to do it, like the formal way. Which one would you want to try?
What do you mean, like plug in just a 0, right?
Yeah, you can plug in a
Or-
0, and then you can also plug in a negative 6, and then you can also plug in a positive 6. I think the 0 is going to work, but let's try plugging in the 0 first.
All right. So it'd be negative 4. So I'm gonna do 0 or negative 2 times 0
Mm-hmm.
equals 0
Mm-hmm.
plus 6 equals 6.
Mhm.
So that's the value.
So absolute value of regular 6 stays regular 6. So it's negative 4 times regular 6.
Was negative 24.
And that's what you wanted. So 0 is an answer. Now we just have to check and see if negative 6 is an answer or if 6 is an answer.
All right, so negative times 6 is negative 12
Okay.
plus 6, negative 6.
Okay, and then the absolute value of negative 6.
It'll be regular 6.
And then
And
regular
it's going to be
6.
times -4 equals -24.
So, which one's the answer?
So it's the third one.
Yeah, because it had both 0 and 6. Yeah.
They both would.
Which number line represents the solution? You see the first number line? It's telling you. It's telling you. Like it's telling you two answers. -6, you can try and plug that in, and -2, you can try and plug that in, and see if you get like 2 in the equation. It's just telling you two answers that you can plug in.
Points. Okay. So it could be a -6 +4.
Which would be
4 equals -2.
And then the absolute value
would be 2.
So that one works. Now try plug in the other one.
So that one equals 2 also.
So that one works. If you tried to plug in the others, they wouldn't work out. You can try.
It wouldn't work.
Yeah, you can try them. But which one?
Just the second line one.
Okay.
It would be 6, and the next one would be 8.
Yeah. So they both don't work, and all the other ones wouldn't work as well. Okay. So which equation has no solution? Way at the beginning, when you have an absolute value, it's the distance away from 0. Right? So like, what's that?
So that last one.
No. It's the first one. Because no matter what you plug in, an absolute value can never be negative. Because if you have the distance away from 0 and you're talking about distance without regard to like which direction you're going, it's just regular distance, so it can't be negative. So like, if we look at the simplest example where we had absolute value of x equals 3, you plug in a -3, and the absolute value changes it to positive. You plug in a +3, and the absolute value keeps it a positive. There's no way that the absolute value changes something into a negative number. So there's no way, no matter what you plug in for that 4x minus 2, no matter what you plug in, after you do the absolute value, whatever that comes out is always going to be a positive number. There's no way to get a -6 because absolute values don't give you negatives. Does that make sense?
Yeah.
So the only one is the first one. Like there's some other like tricky things that they might say, but if we run into those tricky things, we'll pause it and I'll show you. But absolute values all by themselves without any numbers in the front of the absolute value or any numbers after the absolute value before the equal sign, they can never be negative. They would always be no solution. If it's just a single absolute value equals a negative, then the answer is no solution.
Would it be the second one?
Yeah, I think so. Because could have gone down the road 4 blocks in either direction. So if you start at 1/12 and you subtract x, which would be, well, it doesn't even tell you what x is, but it says if shared, which equation could be used to find x would be the block numbers that represent, which could be used to find the block numbers that represent the farthest distance that the turtle may be. It would be the second one, B.
Okay.
Because the farthest in either direction is 4, so like the absolute value of the distance between 1/12 and whatever the turtle traveled would be 4. Yeah. That's so weird. All right, on this one you can plug in stuff. So let me know what you're plugging in, and I'll check you as you go.
All right, I'll do the -3.
Okay.
Let me just get the value. 2.2 6.6 subtract 2.3.
And you plugged in the -3?
The -3 I just subtracted.
And what did you get?
Yeah, I plugged in so I got 9.9 after I subtracted the 3.3.
You plugged in a +3 or a -3?
Negative.
So you should get a -9.9 before you do the absolute value.
That's what
okay. Okay. And then you do the absolute value.
So that's the absolute value. So now it's 9.9.
So regular 9.9. Okay. And then what do you do with that?
Multiply it by -2.
Yeah.
Equals negative 19.8.
That's what I got. So -3 doesn't work, which means the first answer and the third answer don't work, right?
Yeah. So let's do 3.2 times 3 equals 6.6. So I got 3.3 for the absolute value times 2 negative equals 6.6.
Negative.
-6%. Yeah. And then
so that one works.
Yeah, so that was the regular 3. Then we gotta try 0, right? Because okay, so now I got 3.3, and then I'm gonna times 2. All right, so that one works too.
Yep. All right, that's not too bad.
Yeah, it's not too bad. So I'll do the same for these, right?
Yep.
So 6 negative -5 equals 11.
And if one of them doesn't work, then you know it's not the answer, so you don't have to check the other one.
Yeah, so I already did the... So it's the second one.
Yeah.
Doesn't matter.
Yeah, that's not bad. Once you know how to plug stuff in, then we get to these.
Yeah.
So these are the weird ones, I feel like. What?
He needs to just leave her alone.
uh,
Just pay her. Good idiot.
the other one
So
made
he
more
has
sense.
$42 in his wallet.
Yeah. Oh, and so like if he has, or if he ends up with, I think it's the first one. If he ends up with he has $42. Well, maybe it's not the first one. Hold on. Which represents the amount of money he may have after he sees Rita. This is so stupid.
The internet is saying it's the first one.
Yeah, that's my guess. I just because it has the minus sign, but because like if he ends up having $12 less than, like that means he owed her, and so what would that be, like $30.80 minus
Right?
42.80? That will equal negative 12, but then you do the absolute value equals positive 12. But if you do it the other way, where she pays him $12, then it would be like 54.80, and then 54.80 minus 42. It's yeah, I agree with that, but I think that one's stupid.
Yeah, I know. I guess I just plug these guys in, right? Or no, why does it have a negative on the out
Right.
there on its own?
Yeah, so that's the same thing as a -1 times the absolute value, 2x minus 10. So, since there is no number, it's like a -1.
Oh, okay, so number.
This one's, I feel like, a trick question. I think it's the third one. If you tried to plug in either of those, it shouldn't work. Like if you, let's see, if you plug in 3.5, so 3.5 times 2 equals 7. 7 minus 10 equals -3. And then you do the absolute value, which is positive 3. But then there's that negative on the left side. So that makes it back into -3.
And
then -3 minus 1. -3 minus 1 is -4. So that doesn't work. And then if you did the -6.5, 6.5 negative times 2 equals -13 minus 10 equals -23. The absolute value makes it into a positive 23, but then the negative makes it back into a -23 minus 1 equals negative 24, which is also not 2. There is no solution to this. Okay, which one do you think? This one's like the other one that we did.
Negative 8, yeah.
Yeah.
The only reason I thought it was 0 for some reason, just because I don't know. Yeah.
Because no solution said like you associate that with 0, right? Because no solution equals 0.
Yeah.
Like 0 and no solution, but it's absolute values can never give you a negative number. All right, let's see what we got. Sweet.
Okay.
I feel like that was maybe one of the more complicated ones. Like both the last 2 sections. I feel like those were.
Yeah, with the numbers and all. I mean, it's not bad.
When we got into the pattern of plugging in stuff, it wasn't too bad. All right, what's this?
I don't know if you want. I gotta go to sleep because I gotta get up early tomorrow. But if you want something to say about this,
solving one variable.
Or you got something to say?
No, we can talk tomorrow. I'll let you go.
Okay, yeah. Just text me if you. I'll be available tomorrow.
Okay, sounds good.
You got something on? Just text me.
Yeah, I'll let you know.
Thanks.
Night, dude.
All right, bye.